SALT Science Engagement astronomer, Dr. Daniel Kahnemer, joins us now to explain what this is all about. Dr. Kahnemer, good evening, and thank you for your time. It sounds eerie at best, but perhaps in very layman's terms, what is dark energy?
Good evening. So in simple terms, what dark energy is it's a phenomena that we observe. We observe when we look at galaxies far, far away. The further we look away, the faster these galaxies are moving away from us. So, and that goes at an increasing rate. So what we can determine from that is that the universe is not just expanding, but it's expanding faster and faster. It's accelerating in its expansion. And this phenomena, which we observe, has to be explained by some sort of force. And that is the force we call dark energy.
And do we know at all or have an idea of what lies within these galaxies, you know?
So we have a very good idea of galaxies. We have a very good understanding of galaxies and what makes them up in terms of the stars. There is something else in galaxies called dark matter, which is required to hold them together. But what we're talking about here is the space in between the galaxies, and that space is expanding at an increasingly large rate. And the force that is required to do that is what we call dark energy.
Perhaps let's also then look at how you're studying the stars that have died hundreds of millions of years ago, also as the work that you're doing into dark energy.
Yeah, so what SALT has done and is doing currently is playing a very important role in this. So how we determine the distances to these very far galaxies, and therefore whether they're moving away from us, is by looking at stars exploding, as you said, supernova. So these supernovae are going off all the time, and they're very, very bright. So you can see them across the universe. Sometimes they shine as bright as a galaxy itself. And a particular type of these supernova is very well understood. So if we can see it and identify it as that particular type, we can predict its curve and we can get a very accurate distance for that galaxy. But identifying these stars is one thing, but then classifying them as this particular type is very, very difficult. And you need a very, very powerful telescope that can take a spectra of the star on a very short time scale. And that is where SALT comes in. It's a very powerful telescope, the fourth largest in the world, and it is playing an important role in following up these stars, identifying them as these type 1A supernova, and therefore using them to measure distances to galaxies.
How important is it that South Africa has this kind of technology and I think is able to play in a global space, especially when it comes to exploring what lies in the universe?
I think South Africa is doing incredibly. The SALT telescope was started construction. It was completed about 2005 and commenced full science operations in about 2011. And since then has become a world-leading telescope. There have been many scientific discoveries that we've been involved in, a very large one last year to do with gravitational waves. But in terms of South Africa, there is so much more than SALT. We have about 15 telescopes at the South African Astronomical Observatory in Sutherland, all doing different science. And then, in addition to that, the Square Kilometre Array will be arriving in 2024. And Meerkat went online recently, just outside Carnarvon, which is the most powerful radio telescope of its kind. And that's right here in South Africa. We really are world leaders.
And what purpose do you feel that having all of this research and putting all of this money and effort into it, what purpose does it play for South Africa and I think also for the world?
Well, I mean, I think for South Africa in particular, it's very, very important. We're developing the next generation of scientists right here in Africa. We're training them. They're having the opportunity to work on these world-class telescopes for their PhD projects and beyond that. SALT is a 35% South African project, and we encourage South African graduate students to get involved in the science. So we really are putting our individual scientists, as we're training them, on the world stage immediately. So I think it's very important from that perspective.
All right.
And then just in terms of investment, I mean, the SALT telescope was a technological coup for us. We showed the world we were capable of constructing such an incredible device. And that played a very important role in us securing the bid for SKA, which is going to pour billions into the South African economy.
And just before I let you go, for those people who have an interest in the kind of work that you're doing, especially perhaps even students, you talk about graduates who also have an opportunity to get involved, where can they go? An easy access portal that perhaps they can just log on to in order to get more information?
Yeah, so the SAO website, sao.ac.za, is a good start. Otherwise, you can just look for SAO. We're on Twitter, Facebook, Instagram even now.
All right, fantastic. Thank you so much for your time tonight. That was a South African Astronomical Observatory Science Engagement Astronomer, Dr. Daniel Kahneman.